Hey everyone, I'm Praveen and welcome to AI Sparks, where artificial intelligence meets innovation and excitement. On this channel, we spark curiosity and ignite imagination with AI powered insights, tutorials, and explorations. From machine learning to robotics, we'll dive into the future today. Judge first, think later, a story about teaching AI to reason better. Let me start with a scene you might recognize. Imagine a student solving a math problem. They write, erase, second guess, write again, pages fill up. Eventually, the answer is correct, but the path is a mess. Now imagine a different student. They pause. They quietly rule out bad ideas in their head. Then they write just what matters. This paper is about turning today's AI from the first student into the second. The paper is titled Judge First, Generate Second for Efficient Reasoning. It's by Jiangshan Duo and Hanyu Li, along with collaborators from Peking University and Xiaomi. Here's the core problem. Modern large language models are trained with something called reinforcement learning with verifiable rewards, or RLVR. It checks only one thing. Is the final answer correct? Sounds reasonable, but there's a catch. When you only reward the final answer, the model starts thinking out loud a lot. It explores every path, backtracks constantly, uses words like but, however. Let me try again. The result? Correct answers, wrapped in thousands of wasted tokens. People tried to fix this by penalizing long outputs, but that's like telling a student, write less but don't think less, unquote. It often cuts off important reasoning and hurts accuracy. So the authors ask a different question. What if good reasoning isn't about searching harder, but about rejecting bad ideas earlier? This leads to the key insight of the paper. Efficient reasoning starts with judgment. Before a model learns how to generate solutions, it should learn how to recognize good ones. That's JudgeRLVR. The method has two stages. Stage 1, judging. The model is shown a problem and a proposed solution. Some are right, some are wrong, but very close. The model's job is simple. Decide correct or incorrect. This stage is powerful. It teaches the model what valid reasoning looks like, not by solving, but by evaluating. Stage 2, generating. Now, the same model is trained to solve problems using standard RLVR, but it starts with a built in sense of judgment. So, when it begins generating, it quietly prunes bad paths internally. No explicit length penalties, no rules saying be concise. Conciseness just emerges. The results are striking. On math benchmarks, accuracy goes up, but average output length drops by about 42%. Even more interesting, the gains transfer. Science questions, coding tasks, general knowledge. The model doesn't just get shorter, it gets calmer, more decisive, less self doubt in text. There's also a big pitfall the paper exposes. If you only train the judge and stop there, generation actually gets worse. The model over explains. It turns into a paranoid proof checker. Judging is necessary but not sufficient. You still need the generation stage to turn judgment into action. The practical takeaway, if you're training reasoning models, don't just reward answers. Teach models what bad reasoning looks like first. Because once a model knows how to judge well, generation becomes almost inevitable. And that leads to the paper's final, almost philosophical line. To generate is simply to judge so well that the correct answer is the only thing left to say, unquote. If you found this helpful, hit like, subscribe, and comment which AI system you want to build next. Stay sparked. See you in the next video.